Hello, everyone. I would like to give you a warm welcome from Atos team. So we would like to say how grateful we are to see you all here. I'm here myself, Konrad Słapa and Jarek Gajewski. Today we're going to talk to you about cloud-native application and the challenges that we actually see with our customers, how to adopt them. Okay, so short agenda. What we want to do is the keynote. So we want to understand, we want to introduce ourselves, but also want to understand your background, guys, because we know we are either developers or sysops, so we want to understand what's your knowledge, what's your background. Okay, then we're going to talk a little bit about the trends that we see now in IT. We're going to talk about containers. We're going to talk about specifically about orchestration of containers. We're also going to talk about those challenges that we mentioned already that the organizations have. And we have quite a nice demo, I think, about how to implement cloud-native applications. And hopefully we'll have some time for questions. But don't worry, if we don't have time, we know we are doing this for the first time here. If we don't have time for questions, don't hesitate to meet us after this presentation. So just reach us. We'll be more than grateful to answer any questions you guys might have. Okay, Jarek, can you say a few words about yourself?
Sure. So I'm working for Atos as a lead cloud architect. My responsibility is mostly focused on the private and hybrid cloud. I'm double VMware certified implementation expert in areas of data center virtualization and cloud management and automation. If you want to reach me, you can find me on Twitter. Konrad, can you briefly also introduce yourself, please?
Yeah, so I work with Jarek. I'm also a lead architect, but in the area of cloud automation. So my background is basically VMware. I've been working with VMware for like maybe 8 years already. I'm also VMware certified. In particular, I am a VMware certified design expert in 2 areas, data center virtualization and cloud automation. If you want to reach me, follow me on Twitter or just reach me after the presentation. We can change the contact. If you guys have any questions, as we said, we are here for networking as well. Okay, we have already introduced ourselves. We would like to ask you a few questions. So who from you are actually from the development backgrounds? Can you just raise your hand? Okay, I would say like maybe a half. Okay, and who's from ops? SysOps. SysOps, guys, admins. I know you guys work with systems, right? Okay, so I understand the rest of you are managers, right? Okay, cool. That's fine. That's fine. Okay, how many of you have heard about containers? Okay, good. That's a lot of people. So we'll do a short introduction anyway. But who has actually implemented and is using the containers in production? Okay, that's great to see. And who has heard about orchestration of containers? Okay, and who's using this in production? Okay, a little bit less people, but we'll try to show you how you can do it and what benefits we get from it. Okay, so we would like to start with this buzzword that every one of you probably has heard, digital transformation. Yeah? So digital transformation is not actually about the particular technology, it's the change of the mindset, how the organization works. However, we want to look at it from the perspective of our IT pros or developers. So what can we do to help our organization to go through this digital transformation? So what we have actually noticed is that what our customers, but Atos is also doing, is the transformation of how we deliver the application, the architecture. So what's actually happening right now is that we had this monolith application that has been delivered for years that are very difficult to update. They're difficult to deploy. What's happening, we are moving toward the cloud native. So we pick pieces of the application, different services, processes, and we put them into microservices. What this gives us is that we can actually work on each of the services separately. We can deploy faster, we can develop faster, we can do rollbacks, and also we can fail faster and understand what the issues were and roll back. The other shift, other shift that's probably not so good for the sysops guys is that we are moving toward the, and we need to get used to this, is the philosophy of site reliability engineering, which means that we actually are moving from the old way of working where we had the availability policies before on the infrastructure side. So we've been using technologies which were really exciting, like 8 years ago, high availability on vSphere, site reliability manager who allowed us to fail over the virtual machines from one data center to other. This is really shifting towards the application. So, we're moving more and more workloads into public cloud. So as you know, the infrastructure in public cloud is not as resilient, and we don't have all those SLAs, maybe except Azure that gives us the SLA for the infrastructure. We don't have those SLAs in the public cloud. So the responsibility for availability policies is shifting toward the developers or SREs. Okay, so let's look quickly at the evolution of compute. We have different types of compute right now. We have infrastructure as a service. We have we have container platforms. We have application platform, and also function platform. So function as a service. We have now software as a platform. What we observe with our customers, with large enterprises, is that though everything needs to fit for purpose. Yeah, you can't use function for a service for all the services that or the application that our customers deliver. What is very important for the enterprises is that they can follow their security policies, in general, the policies they have. So what we see to bring the cloud-native applications and be able to introduce all those policies, the container platform is the most suitable. Okay, and if we talk about container as a service, we see that there are two technologies which are definitely the leaders. What you see here, those are the statistics from Stack Overflow. So probably the developers know what the portal is. It's basically a forum where you ask questions on mainly on development. So you can see that from 2013, the interest in Docker and in Kubernetes, it has been rising almost exponentially. So we can see, you also, Jarek will show how many Kubernetes implementation are there comparing to other technologies. However, you can see that there are the leaders right now. Okay, quickly about containers. I know I've seen like 80% of you already know what the containers are. We won't go into the details. I like to compare this to the virtual machine. So the difference from the virtual machine is that actually the containers are running on the operating system, and then you have a Docker engine that's actually providing this containerization. So the virtual machine, it's not a virtual machine, it's a container. The container is a separate process within this operating system, and they're completely separate. What it gives us is the speed of deployment. So when you deploy a when you deploy your application, when you deploy your microservice, you're starting only the container. So it can start within seconds, not within minutes, or when you know how much time it took to boot some massive application. The portability gives you, well, when you define the container, you have all your dependencies, and you know that if you deploy the virtual machine in your development environment, you can also deploy it in production, having all those dependencies. The efficiency means that you can actually use your resources better, because you can pack all those services into virtual machines. You don't have so much waste on your CPU and memory. Okay, quickly, how the Docker works. It's a very high level. We don't have time to go into the details, but basically you create your images, you put them in the registry, and then you can just pull them and run them in your production environment. So this sounds really simple, right? So you might say, oh, I want to use Docker, but then you go into the enterprise where you have large applications, and that's what you get. So you have thousands of containers, you don't know how to manage them, and this looks like it's all going to collapse. You have so many challenges about networking, about the security and so on, but I hope that, Jarek, you can tell us a little bit more about this.
Yeah, indeed, huge amount of containers can cause a headache. Most of people in that room seems to be developers, so they just want to get containers. The solution for massive container implementation is to orchestrate it. But such orchestrator need to provide us particular capabilities out of the box, like capabilities to redistribute the containers across container hosts depending on the resource consumption, capabilities to monitor those containers and react in case of their failures to recover it in an automatic fashion. It's also quite important to have capabilities to resize containers, to depending on the application demand and so on. Of course, none of our applications and containers can work without network connectivity, so it should be also delivered on demand, including the services that are on top of our network infrastructure. Many applications required access to the external resources like databases, so it's also quite important, or required access to the persistent storage to store data that can be accessible even if our containers are not live. So in 2003, Google decided to introduce their own project, Borg, and in 2014, they moved it as an open source Kubernetes project to the community. On the Conrad's diagrams, you've seen that in the middle of 2014, the Kubernetes usage already grew up, and multiple vendors, companies decided to switch into that orchestration tool because it's already addressed all challenges that we've got with the containers comparing to other competitors on the market. So, how many of you is using already virtualization infrastructure to host your applications? And do you, who is using already VMware platform? It's very hard to change it, so we are intended to introduce containers to the enterprises, but enterprises don't want to change the baselines that they've already have. They want to have containers implemented in line with their existing security policies. They want to have containers that will coexist on the software-defined networking. They want to have containers that will be easily managed from the lifecycle perspective. I haven't seen any company that do not using already role-based access control. And due to massive amount of applications and elements in our enterprises, the day-to-day operations are very complex. So introducing new extremely complex application or element is also not welcome. From the security perspective, all images, binaries that we are using in the companies, like operating system images, application images, they need to be properly hardened and properly approved by our security officers and so on. Anyone already had a chance to deploy Kubernetes manually on your environment? Do you think it's easy? Yeah, it's challenging. I was trying to do that as well. So VMware, Pivotal, and Google decided to address those challenges. They introduced Pivotal Container Services, PKS, to automate the deployment and to introduce containers to the large enterprises. Bosch, that is part of PKS, is providing capabilities to manage our infrastructure in the automatic fashion, to automatically provision, configure and maintain the infrastructure elements that are working as a background for our containers. We are getting also the Kubernetes as a service, so we can get new Kubernetes cluster in 15-20 minutes. We can rescale it on demand. We can remove it if it's not needed anymore, releasing resources. Many companies has challenge with storing images on the public resources. So we got Harbor, our container registry, that is providing for us space for our applications, that is providing us a security view into problems with our application images, and provides us also the capabilities to sign our images. Last but not least is the networking. So In advanced networking implementation for pivotal container services, we've got NSX-T. Anyone of you already have a chance to work with NSX-T? Thank you. So NSX-T is capable to leverage namespaces and transfer them into logical routers and logical switches on the software-defined networking infrastructure. It's capable to translate the network policy into firewall rules for our SDN, and is capable to provide you integrated with PKS on-demand load balancers. Even more, if you've got already SDN based on NSX-T, it can coexist with your standard infrastructure as a service offering. So you can still have your virtual machines that coexist in same SDN. You can still have capabilities to introduce the policies that are mandatory for your company and force them across the policies that you will define for your containers, keeping the developers' capabilities to define the inter and intra-application connectivity for you. So to stop talking, we would like right now to provide you some demo, so how it works in practice. We will divide the demo into two pieces. First piece will be led by Konrad, second by me. So Konrad, can you say what you will present on your part?
Sure. I hope we haven't confused you that much yet. So what we are going to show you is actually how we deploy the Kubernetes cluster. So what we have here, we abstracted the containers, the pivotal container services. We just made it. Sorry about that. Okay. So we abstracted the container service. We don't want to look into what's inside there because that's deployed automatically. So what we care is actually our Kubernetes cluster that we will deploy here. So we can decide how many nodes we need. So the Kubernetes actually has the master node and worker nodes. That's where you can actually put your workloads. So this can be deployed automatically. So that will be the first part that we deploy. And the second part is that I will actually deploy an application, a very simple application that was written by the VMware guys. It's an application that allows you to vote for your favorite restaurant. And it contains the front-end application service, cache, and database. Okay, so knowing that, let's go to the demo. Okay, we have the demo recorded, unfortunately, because it takes, as Jarek said, it takes about 15 to 20 minutes to have the cluster deployed. So that's why we need to record this. Okay, it will be mostly the command line. However, it's pretty simple. You just have few commands that you need to run to deploy your Kubernetes cluster. Okay, so we are here in the command line. I'm gonna just paste I'm gonna log in to the PKS cluster.
Conrad.
Sorry about that. Okay, so what I have already done here, I log in into PKS cluster. And what I'm doing here, I'm creating the cluster with just the name and saying what plan it is. So it will, you can define different plans. You can call them whatever you want, and they will actually deploy number of nodes that you require. So the cluster is being deployed right now. So you see that what I have actually requested is just one node. It's just one node here that's being deployed. And what we have in the background is vSphere. So I have checked what's the status of the cluster. I had already one cluster provision before. The second cluster is being deployed. So you can check the status. It took me about 15 minutes to get that cluster working. Okay, let me speed up this a little bit. Okay, so we can actually go to vSphere, vSphere client, and see what's happening in there. So you see that there have been some machines provisioned, but we don't really need to care about this because our front end is the PKS. So I just need one command to deploy a new cluster. So there is if you look in the vSphere client, you see all those strange names. You don't really need to care about those names because it's the PKS that will deploy those virtual machines. It will delete those virtual machines. So the vSphere side of this is completely abstract to you. You don't really need to care about it. Okay, the cluster is still provisioning. The only thing you can actually do is just to get the status again and again.
Unfortunately, you will not get an email that is already created yet.
I think you can get it if you spend some
if you orchestrate it.
Yeah. Okay, so you can see that there's stuff going on in the background. Let's speed this up a little bit more.
The creation time is also quite dependent on the amount of workers nodes that you have defined in your plan.
Yeah, so each of the worker is actually a virtual machine on a vSphere cluster. Okay, so we see this is. Let's check the status again. Still in progress. Okay, and the cluster has been, so we get our cluster, bITconf 1, we see that there is one node. What we can do now is you want to extend this cluster to more nodes because you want to have containers that are replicated, so you want to have more replicas of this. So we can simply do it by resizing the cluster. So there is a command resize, PKS resize, and you say how many nodes you want. Okay, so we didn't get any response. However, this is working in the background. You can actually get the the cluster status. So you will see that this is in progress right now, and you have 2 nodes. Okay, so again, you can go into vSphere, check what's happening in there, but basically you just need to wait 10 to 15 minutes to get another node in place. Okay, let me speed this up. Okay, so we can actually see now that the cluster has been provisioned here. I speeded up the demo. However, you can see that the cluster has now 2 nodes. It has been successful, and you can get the namespaces. So those are the abstracts, Kubernetes abstracts that show you that are putting together some pods with the same networking and so on. So you can see that there are already some namespace created by PKS itself. What I'm going to do right now is to create this new namespace. So we have the cluster already, but we just want to create a new namespace. Okay, let me now switch the demo. Oops. Okay, so I simply have a cluster. I don't have any workloads right now. So what I want to do is to create a new namespace. And as Jarek said, when creating a new namespace, PKS is talking to the underlying infrastructure. So you don't need to care. When you're using Kubernetes, you always need some infrastructure in the background because it's abstracting the infrastructure. However, the providers, they need to write interfaces for this. So what we're doing, we're creating the new namespace. The new namespace has been created. We are changing the context to this namespace, and now we will see what has actually happened in NSX-T. So this is the console. If you guys, I've seen not many people have used NSX. However, this is the console for NSX, and we can see what has been actually created automatically for us. So we're logging to the console, and what Jarek has already said, we will create, PKS would create for us the router and the switch that will be then used by our containers. So we're going to the routers. And here, hold on, just needs to search for it. So we have the router created here, bITconf 2018. And this is related to the namespace we have created. Okay? And we can see some details about this router. This is a tier 1 router that is used for containers network. And then we move to the switch table. So we can see that the switch has also been created. We can search here for bITconf. Okay, and we have the bITconf switch created. So what we have right now is the cluster, the Kubernetes cluster, and we have created a namespace where we can deploy our application. What we do next is deployment of the application I have been telling you about. So this is the application that contains 4 different pods, and you will see how quick that is. Okay, so to deploy the application in Kubernetes, you define, so you can call it manifest in format of YAML. So it's, if you know XML or CSV formats, it's a different format of defining infrastructure. You use it also for CloudFormation templates in AWS. So what we have here is the template. Sorry, is the manifest. So we can see that we will be deploying a load balancer and it will be connected to this particular pod. We don't need to go into the details because it's we don't have time to do this. But basically, I wanted to show you that this is how you define your application. And the images that we're gonna take the images from the harbor. So the registry of the containers. Okay, so this is the harbor that Jarek was talking about. So it's basically a registry of your images. It's on-premise. It allows you to scan for vulnerabilities. So it's not like Docker Hub that's placed somewhere in the cloud. It's on-premise. So you have a full control over it. Okay, so those are the 4 images that we're going to deploy. We have the front end. We have the Redis. We have database. And we have the application server. So now, this is the magic that's going to happen right now. So we're using a simple command of kubectl to deploy this application. We're taking this YAML file that will tell Kubernetes to deploy this application from those containers, put them in the particular namespace that we have defined, and there we go. So okay, I'll pause it for a second. Hopefully you can guys see it, what has been actually deployed. So what has been deployed are those 4 containers, 4 pods, and the services. And one of these services is actually containing a load balancer. So this is actually, now you need to wait for those containers to run. However, that's all you actually need to do to deploy your application. Okay, so we are now checking the status of the pod. So you can see that 1 pod has been already created, it's running, and we have 3 more containers to be deployed. So it's gonna, as I said, the containers are just starting in a matter of seconds because the operating system is already up. Okay, and we can see that all the containers are up, so the application should be up as well. What we want to, how do we connect to this application? So we said that there is a load balancer in front of the application. So what we need to get now is the IP of the load balancer. Obviously, that's a very simple presentation we're showing. We can also use DNS names, but we'll just grab this IP address of the load balancer. We'll put it into our browser and see if the application is up. Here we go. So we're connecting to our application, and now we can vote for our favorite restaurant. Let's check if it actually works, if it can write to the database. Yes, I have voted for this particular restaurant, and this has been stored in a database. Okay, one more thing, as I said, the load balancer, it's not part of Kubernetes. The Kubernetes is abstracting, it's leveraging the infrastructure, and the actual load balancer has been created when we deploy the application. So you can go to NSX, and you can find the actual load balancer that has been created, and you can find, you see that's the virtual server that we connected to, and you can also see the virtual machines that has been connected to that load balancer. Okay, so that's it for the demo. So just to sum up, we deployed the cluster, and in a matter of seconds, we deployed an full application coming from our repository. Okay, now we will switch. We have another demo showing the security policies.
Yeah, so Konrad shows you how to leverage Kubernetes for deployment and how to leverage PKS to get containers on demand. I will focus more on the security part of that. So what I will present, I will create new, not much. Okay, I will create a new network policy that will allow for communication based on labels in our pods from Redis labeled pods to guestbook labeled pods on port 80 only. That application, bITconf guestbook, will consist of 6 pods and the front-end load balancer that will be also labeled as a guestbook, so it will be included in our firewall policy. On the next step, I will try, or I will validate if the connectivity is working as expected. I will try to connect from my management network to that load balancer to check if it will be denied, in fact. Then I will deploy another application in same namespace, in same IP subnet, to validate communication from that DB pod to my guestbook pod and to my Redis pod. And we'll check the effects. At the end, I will allow communication from all subnets on all ports to my guestbook pods and present it as well. So, Konrad, can I ask for a demo?
Yeah, sure.
I was trying to make it big. So we've got YAML file that is defining our new policy. I think, Konrad, it's not full view, or okay, it's cut somehow. We've got our bITconf policy. We've got the label for the pod selectors, Redis as a source, guestbook as destination on port 80 only. We will apply that policy through our Kubernetes console. Then we are switching to NSX-T underlying layer. We see that new group for our cluster was created based on namespace that we've got. We see that there are no members there. That means that we don't have any pods there. We've got 2 IP sets, one for source and one for destination. In the source one, we see that it's gathering members based on label Redis. And on the destination, we see that it's gathering members based on label guestbook. In the firewall section, we can also define the exceptions. Then third IP set would pop up and would be also presented there. In firewall section, we need to find the policy that that is created in automatic fashion. That policy will have the auto-generated name and will present IP set as a source and destination and services. So we can see in the source we don't have any members already, so nothing is allowed. In the destination, same, and the current services that are already applied on that policy are only related to TCP/IP on port 80. On the next step, we will deploy our new application. Our new application will be based on 6 pods. 3 of them will be tagged or labeled as Redis. 3 of them will be labeled as guestbook. We can see it's quite fast to deliver it. We can see the labels there. All of them have already gathered IP addresses. There. In normal demo, it was visible. I don't know why it's not fully. Yeah. Then when we go to our SDN management console, we see that in the group that we created, namespace, we've got new members. We've got new 6 members already defined there. In the IP says automatically 3 members were added, and it's not there, sorry. Yeah, 3 members were added to source and destination based on our own labels that developer defined for his pod. And same is on the firewall rule. So the membership of the source and destination was already updated. It's not only IPs, it's also interfaces. So it's just for demo purpose. So to validate that it's working, we will connect to Redis labeled pod, one of the Redis labeled pod, and try connectivity from there. To make sure that the info that we've got on the Kubernetes console is same as in the pod itself, we're checking the IP address. It's same, believe me. And then we are trying to query one of our guest book labeled pods on port 80, with expectations that it will be success. Yep, we've done it. So, as the next stage, we deployed application that has load balancer. Load balancer, as I mentioned, is also labeled as a guest book. So we shouldn't have a chance to get it, to access it currently, because our source is not in the source list of the firewall rules. It's loading. That page is already stored in my cache. Sorry, forget to clean it. So it's loading, but it will be not successful. So we can switch right now to the second part of that demo. And we will deploy additional application in the same subnet, in the same namespace, same broadcast domain, to check how another developer working on the same cluster can interact with my own application. That application has different labels. So it has label DB and web, completely different from that what we've got defined. So as a result, we are expecting that those new IPs assigned will be presented or updated in our namespace. We see now we've got 8 members, 2 more. But the existing membership for source and destination was not updated. I don't know why it happened. Yeah. To prove that that application cannot access my own pod, I will connect to database, to DB labeled pod, and try to do same as I've done already on the Redis labeled pod. So to query that application on port 80. When I'm connected, I'm checking, confirming the IP address that is used for that particular pod. And as the next stage, I'm querying the pod guest book on port 80. Yeah. As expected, it's not allowed. That particular pod is not allowed to access my guest book labeled pod. But what about ping request? It's also not allowed. But on the second, on my first Redis pod, I allowed only to access a guest book on port 80. So ping request also failing on both pods. But when we will try to connect those or to access those pods from Redis to DB and from DB to Redis, it succeeds because we haven't defined any network policies for them. and my company default network policy states in same broadcast domain, it's allowed. So now we will change we will modify our network policy, and we will allow all IPs to access my particular guestbook pod on all IP spaces, on all ports. You can see that the source group was updated, and same is represented already in the firewall section. So you see, come on. You can see that on the services we've got now any, and on the source we've got all IPs allowed. To prove that it's working, we will try to access again our guestbook application. I wrote down hello bITconf. Yeah, it's accessible from different subnet because I allowed it on the T1 router, on T0 router. So my company allows communication between those two subnets on the higher level. And I will test same for our already deployed DB and ready spots. We can see that both are capable to query guest app on port 80. We can see that both can ping right now our guest book pods, because it's also allowed on all ports and protocols that we are using. Yeah. So that all what I was intended to show you in my demo. Initially we were intended to show you more, but we've got only 45 minutes, and it's hard to compress everything and show you as much. I hope it was informative for you. Konrad, do we have any time for questions still?
Yeah, I think let's sum up what we have been showing here, because it might be, we're coming from two different backgrounds, right? Developers and operations. So developers been using containers for, I believe, for years, right? The problem about the containers is really that you can't just take them and put them into the production, especially to their large environment. So you really need to understand how you take them, how you orchestrate them. And it's not a simple task, between different clouds, between, you need a way, you need a platform that will allow you to move your application actually from your VMware environment, because that's what you have on premise, yeah? You always have VMware. You can have maybe some Hyper-V still somewhere there, but maybe not really. You need to have an orchestration platform that will allow you to move from one cloud to other and make this portability, right? So we're not saying the PKS is the solution for everything, because it's still, it is developed as well in an agile way. So it's adding new features and so on. But this is one of the solutions that you guys might have a look at. I think, if you need more information about this, reach us after the presentation.
Yeah,
there also, VMware offers some hands-on labs. So you can actually log in there, set up your own PKS environment, and play with it. So you can see all the stuff that we've been showing here, and maybe on your own pace, see what you can deliver. Yep.
And if you are the developer, just a request from your infrastructure guys, containers on demand.
We want to say again how happy we are to see all you guys here. It means a lot to us that we can speak to you about something that we do for really large customers, and where we're moving towards. So thanks again. Thank you so much, and hope to have a good bITconf day. Thank you.
Thank you.